We are now on question number 23, that's exercise 6.2. The question says that if the first and the nth term of an AP are A and B, that means the first term is A and the nth term is B. Further, it is given that the product of the first n terms is P being the product, and we have to derive this relation, that is P square is equal to AB whole raised to the power n. So let's write out the informations. First, we have A as A only. I can still write A as A big A. And nth term in a GP is written as AR raised to the power n minus 1, which is given as B. P being the product, how do we obtain P of the n terms? That is first term into second term, that multiplied by the third term into fourth term, and so on up to A raised to the power n minus 1. Now I'm segregating A and R here. As you can see, A being multiplied n number of times. Starting from here till here, n is being multiplied by n number of times. So A being multiplied n number of times is A raised to the power n, right? Do not get confused with this. 3 being multiplied, say for example, if I say 3 being multiplied 5 times is 3 raised to the power 5, not 3 into 5, right? So many a times you end up writing this as an and not A raised to the power n. Now later writing the other, that is R here, this is R raised to the power 1 into R raised to the power 2 into R raised to the power 3 into R raised to the power 4, and then R raised to the power n minus 1. Now in the next step, we'll write A raised to the power n, applying laws of exponent here, right? Same basis multiply, powers are added. So we'll get R raised to the power 1 plus 2 plus 3 plus 4 till n minus 1. Now this is, as you can see, this is sum of first n natural number, although we have a direct formula for this, but a part of it is deleted. So you may calculate it, like say I'm calculating this part here. In this question, the sum of first n terms. What I'm doing here is simply calculating. Well, as I said, we can directly write this as sum of first n terms, but if you do not remember that formula, still you can do it by adding this. Sum of first n terms, the general formula is n by 2 bracket 2a plus n minus 1d. Need to be very careful that here n is not n, is n minus 1 for this formula. So I'm going to place this Sn here, n being replaced by n minus 1 by 2. 2 into a is 1, so 2 times 1 is 1, plus n is replaced by n minus 1 plus n minus 1 minus 1. That is n minus 2, or you write in the next step, into d. So we got Sn as n minus 1 by 2. So d is also 1. So we'll minus 2 and 2 get cancelled, we get n here. So that means now I'm placing it here. A raised to the power n, R raised to the power n multiplied by n minus 1 by 2. And just a rearrangement, right? This is what the Sn. So this is no more needed. And as I said, you can do it directly. So we got this. Now let's come to the verification part. What do we have to prove here? We have obtained all informations that's given here. And now next, what we have to do is to place these values on the LHS and RHS. So let's make some space here. So what we have to verify is P square as AB raised to the power n. So let's obtain P square as LHS. LHS is P square. So P being this, as you can see, I'm placing a square over here. AN R raised to the power n bracket n minus 1 by 2, the square of this, right? So remember, when we have like something like this, xy whole square, what do we write? We write x square, y square. If you have x, y, z whole square, we write square over each term, each of these factor. So is I'm going to do here. I'm writing a raised to the power 2n and r raised to the power n and minus 1 power into power over power is power multiplied. So this get cancelled. So we finally get LHS as a raised to the power 2n dot r raised to the power n into n minus 1. This is the LHS part for this question. Now coming to RHS, what do we have as RHS? As you can see from here, this is AB whole raised to the power n. AB whole raised to the power n. So A is A, as you can see from here, A is A only, and this is B. So A is A and B is replaced by A r raised to the power n minus 1. And then we have a whole power n as well. So A dot A is A square dot r raised to the power n minus 1, and then a whole power n, which you can further write this as power over power is power multiplied dot a raised to r raised to the power n into n minus 1. What I did here is that I place this n over this, that becomes 2 raised to the power n. And similarly, on placing this n over this, right, being multiplied, we got this. So you can see here that we got LHS as same as RHS. The LHS is and the RHS are same. I'm showing it here. This is the LHS, sorry, this is RHS, and this being the LHS. So this is how it can be verified.